Hi, this is Adit, Cindy, and Jeremy, and for our final project for our computer programming class, we decided to make a water quality testing probe.
Our probe is able to test the conductivity of water, the pH level, the temperature, and the turbidity of the water that it is sitting in. It also can send out a GPS location to the user to let us know where it is at any particular time. And it can also record and send data to the user along with recording data to an SD card. Our water probe uses the Mayfly data logger, which is very similar to the Arduino Mega. It also has sensors connected to it which can read the turbidity, conductivity, pH level, and temperature of the water that it is sitting in. It also uses the AI A7 Thinker GMS module, which sends out its GPS location.
To code our project, we used the Arduino IDE, along with the packages the Arduino API provided and allowed us to install.
We also used coding from Enviro DIY, which is also where we got the Mayfly data logger. We also found coding on GitHub, which we will provide the coding for you with a link in the description below.
So we're here testing this water sample for turbidity, electrical conductivity, pH, and temperature. All these sensors lead into our smart Buoy device and are connected via USB to our serial monitor on my laptop, which I'll pull up for you. First thing we see is it initializes our SD card for all the data readings. We'll get a date and time stamp, battery voltage, current temperature for the water, pH level, turbidity, conductivity, total dissolved solids, and latitude and longitude, which we're not getting a reading on currently. Every 10 seconds it updates, adds the data to a string, and saves to our SD card. This is the device disassembled mostly. I just want to go over some parts. First of all, we've got our turbidity sensor over here with various zip ties that we use to hold it in place for the presentation today. Back here, the blue, we have the pH sensor. Black next to it is the electrical conductivity. And then finally the thermometer. We've got a little power shield, and that sends a 5-volt power to all the sensors. This is our lithium-ion battery that powers the main microprocessor. That is charged via the solar panel up top. And in between the two, we've got various things. First of all, we've got the main microprocessor board. This is the Mayfly data logger. It's got a built-in SD card over here that saves all the data readings that we get. All the sensors lead into it via the digital pins or the analog pins here and here. We follow it up through this polycarbonate disc. We can see all these shields for each individual sensor that leads in, processes the data, and then leads down, plugs into there. So we've got pH and electrical conductivity here, temperature here, and right here we've got the turbidity. Furthermore, we have our GPS board and antenna, which gives us our location of the device. And then coming around this side, you'll see this antenna. This board here is our SIM900 modem, which handles our GSM signal going to our cellular network. Hello, I'm Jeremy. I'm here with Cynthia. Hi. And we're going to wrap up our presentation here. So in conclusion, you've seen a lot of functionality and the components of our, what we're calling our smart buoy. I just wanted to talk about some of the future applications and enhancements we could do. We're thinking we can add some various metal detecting probes, chemical detecting, enhancements there, maybe a video camera to see what's happening in the environment, along with some outboard motors to add mobile functionality, maybe sort of a drone out of it. We also like to get this thing working with the Blink app. So we have a user interface for your smartphone, along with the Freeboard I/O, which is an interface dashboard for your personal computer. And then some of the applications we foresee for this guy is really just maybe deploying any kind of large body of water, river, lake, ocean, maybe developing a network of interconnected devices, sharing and recording data. I'd love to see this thing everywhere, used by the EPA, various industries. I think that we can build this for $100 or so. I think that economically it's viable and has a lot of usage in industry, and hopefully can do a lot of good for the environment.